जियोमेट्री के इस लेक्चर सीरीज में हम पावर ऑफ पॉइंट्स पे बात कर रहे हैं और इससे पहले मैंने पावर ऑफ पॉइंट्स की डेफिनेशन के बारे में पहले बात करी फर्स्ट लेक्चर में. इन सेकेंड लेक्चर आई हैव डिस्कस्ड अ प्रॉब्लम that how we will tackle the directed segment, how we will tackle the directed definition of power of point. And in this lecture, we are just going to deal with a beautiful problem that has been asked, had been asked in USAMO in 1990, right? So let's see what problem is saying here. That let C1 and C2 be the concentric circles. So suppose I am drawing the circles here. Suppose it is C1 and it is what next is C1 and C2 be the concentric circle. C2 is in interior is C2 in the interior of C1. So it is going to be C1 and it is C2 and both are concentric. Concentric means both have the same center, right? From point A on C1, so suppose this is our point P. From this not P, this is A. From this A on C1 draws a tangent AB. This is our AB, right? AB with C1. Let D be the C be the second point of intersection of AB with C1. So it is C, right? And let D be the midpoint of AB. Suppose it is D and midpoint of AB. The line passing through A intersect C2 at A. So the line passing through A like this at E and F, right? It intersects C2 in such a way that perpendicular bisectors of D and CF. So let's go for D and CF. DE and CF, let's take some like this. Suppose let's do like this because they can intersect each other, right? They can be represented like this. So suppose it is E and it is F, right? And it is a D. It is DE and it is CF. After this intersection, what intersection? Perpendicular bisectors, right? Then perpendicular bisectors cut each other at M. So suppose it is our point M, right? What they are saying that find AM over MC. So we will be looking for this. So if we are focusing over AM over MC, AM over MC, it looks like that we must have the some common parameter in which AM and MC, both of them can be represented, and then they will that parameter will get cancelled, right? There will be something common with AM and MC, right? So let's find the point uh, let's find the if we will say that uh, power of B, what will be the power of B? Or some like this, power of A. Let's find power of A. So first of all, to denote in some certain manner, some certain things, to find that parameter in which they can be represented, we will do like this. We will first trigger out the power of points. Let's see the power of points. So I'm discussing power of point A. But with respect to what? So let's suppose with respect to C2, right? So with respect to C2, it will come out to be AB square because it is tangent. So here I have included tangent definition also, right? The power of A with respect to C2 will be like this. But it can also be equal to AE into AF. Done? So suppose it is equation number 1. But the fact is, when I will go for AD, suppose AD into DC. So AD will be something, it is AB by 2. And why I am finding this AD into AC, not DC? I'm just writing this thing. So AD into AC is what? AD is something like AB by 2. What about AC is what? 2AB. That's why I have done this. Because it is going to be AB square. And what does it mean? It means to say that AE into AF equals AD into AC. And what it says? It says that converse of power of a point theorem, if if DE, it will be point F. If DE FC, this quadrilateral is cyclic, then power of point A with respect to the circle which passes through these 4 points will be equal. And that is what it is saying. The converse will say that through all these 4 points, a circle will pass. Right? Through all these 4 points, a circle will pass. So it implies that DEFC is concyclic. And if it is concyclic, we know that if I will draw any perpendicular bisector of any chord, it will pass through center, right? It will pass through center. And what it is happening here is that perpendicular bisector of CF and DE intersect each other at M. What does it mean? It means to say that M is the center. That's why it is common to both of the perpendicular bisector. So M is going to be center. So M is going to be center. What does it mean? That if I'm saying that these all 4 points are concyclic and M lies on DC, and that is the center of this circle, that means DC is the diameter. And if DC is going to be the diameter, right? So if DC is diameter, what will happen? It will happen. See what is going to be. M will be the midpoint of DC. Now MC is equals to half DC. Right? And now, what about DC? Right? So we know that DC will be equals to BC plus BD. So DC will be equals to BC plus BD. And BD is what? Half of BA. And it is going to be 3 by 2 AB. So I have found MC in terms of AB. That is the common parameter. AB is the common parameter. Now, we can say something about AM. So AM will be what? So AM is going to be AB. Do I should say like that? No, I should say like this. AD plus DM. Right? AD is what? AD is something AB by 2. So AD is what? AB by 2. What about DM? So DM is something that DC by 2. And what about DC? DC is going to be DC is going to be 3 by 2 AB, right? So it will be AB by 2 plus 3 by 4 AB, right? And what it will be? 5 AB by 4, right? If we will be writing MC will be half DC, and that is going to be MC is what? 3 AB by 4. Hence, what about AM over MC? AM over MC is going to be 5 by 3. Right? So I have tried to cover all the theory part through these two questions. I will cover another theory parts in my next lecture. Till then, thank you so much.